Welcome, focused learners. Okay, let's dive right into this explainer. Today, we're going to completely zoom out. I want you to look past that tangible physical headset you might strap onto your face. Instead, we're going to explore the massive invisible infrastructure that's actually powering our entirely new 3D world. We're talking about the era of spatial computing, where the digital and physical realms just aren't separate anymore. To guide us through this, we'll use this agenda as our mental map. We're going to cover the spatial computing revolution, hardware and everyday utility, intelligence at the edge, 6G and the invisible web, and finally, the ethics of blended reality. All right, let's get into it. Section 1, the spatial computing revolution. Let's start by laying the foundation for this massive technological shift. Think about it. We are no longer trapped behind flat, two-dimensional screens. Spatial computing enables digital objects, data, and experiences to be anchored directly into your actual physical environment. By using advanced computer vision, AI, and a whole array of sensors, your surroundings are dynamically mapped in real time. You can literally manipulate digital elements as naturally as you would a physical coffee mug on your desk. It's a complete, fundamental paradigm shift in how human beings interact with machines. Moving right along to Section 2, hardware meets everyday utility. Let's look at how this is shifting from experimental prototypes to everyday tools. So, looking at the hardware landscape, Meta currently holds a staggering 74.6% market share in the extended reality space. But there's a real shakeup happening right now. Apple's 2025 Vision Pro push, which features these highly advanced M5 chips and heavy on-device AI, is driving some intense competition. And that competition is pushing the entire industry towards lighter, more powerful, and significantly more capable devices. Here's the really crucial point, though. This hardware, it isn't just a novelty anymore. We're not just talking about playing rhythm games in your living room. With over 40 million units projected to ship annually by 2026, it is completely transforming massive sectors of our economy. Just look at healthcare. 40% of providers are already using VR for patient treatment and staff training. No way, right? We're seeing this tech optimize manufacturing floors, completely enhance complex 3D product design, and fundamentally change knowledge work. And with rumors of new, lighter devices dropping below that $2,000 price point, everyday utility is absolutely here. Which brings us to Section 3, intelligence at the edge. So you might be wondering, how on earth do these untethered headsets process all this heavy 3D data without experiencing massive lag or draining their batteries in 10 minutes? Well, the answer lies in what engineers call the compute continuum. To maintain a perfectly seamless experience, workloads can't all just be beamed back to a distant data center. Instead, tasks are dynamically managed. Think of it kind of like your own workflow. The extreme edge, which is the headset itself, handles immediate tasks, just like the primary workspace right on your physical desk. Slightly heavier tasks get pushed to the edge, nearby network nodes, which is a bit like heading to a local library. And finally, only the most intensive, non-real-time processing goes to the traditional centralized cloud, which acts like a massive national archive. Notice the striking contrast here. Traditional computing relies on continuous, energy-hungry processing. But to support lightweight hardware, we're transitioning to something called neuromorphic computing. Incredibly, this is inspired by the human brain, which, by the way, operates on just about 20 watts of power, roughly the same as a really dim light bulb. These edge chips use event-driven spiking neural networks. That means they only consume energy during specific computational spike events, rather than just constantly burning power. It is a literal order-of-magnitude leap in energy efficiency. All right, let's zoom out even further for Section 4, 6G and the invisible web. What's really fascinating here is seeing this semantic plane and the ISAC framework in action. Notice how those sensing signals bounce right off physical targets, like cars, and return to the network towers. The communication network itself is doing the sensing. This is exactly what we call integrated sensing and communication, or ISAC for short. Basically, in a 6G network, the architecture exploits its own radio signals to act like a giant invisible radar. By analyzing the echoes and reflections of wireless signals, the network continuously maps and updates the physical environment in real time. This is the ultimate invisible infrastructure required for autonomous AI agents and spatial computing to function flawlessly. Your headset doesn't just have to rely on its own cameras anymore, the network itself is telling it where absolutely everything is. And finally, Section 5, the ethics of blended reality. Because with networks capable of continuously sensing our every move, we have to talk about the societal impacts. This puts us at a pretty dramatic crossroads. As spatial computing and autonomous AI become deeply embedded in our cities, the line between human and machine blurs. If our 60 networks and spatial headsets are constantly mapping our living rooms, our offices, and even our physical movements, we face some very serious risks of continuous mass surveillance. And as we look toward even deeper integrations like brain computer interfaces, researchers are warning of the genuinely terrifying prospect of brain jacking, the unauthorized access and manipulation of completely private neural data. Yet, we absolutely must impartially weigh these privacy risks against some incredible benefits. Bioethicists have introduced a really powerful concept, calling these technologies infrastructures of moral inclusion. For instance, brain-computer interfaces are already restoring vital communication for paralyzed patients, allowing them to control devices just with their thoughts. This technology isn't just a fun gadget. For many, it's a literal lifeline that generates an ethical obligation for us to protect and maintain communicative capacity for those who need it most. So, as we wrap up this explainer, I want to leave you with this final provocative thought. The invisible web of spatial computing, powered by cutting-edge headsets, neuromorphic chips, and these massive 6G sensing networks, is already here. The engineering is moving at breakneck speed. But can our ethical frameworks, our human governance, and our society evolve fast enough to guide this newly blended reality responsibly? It's a huge question, and it's one we are all going to have to answer together. Thanks so much for joining me on this deep dive, and I will catch you in the next explainer.